Hello, my name is Mark and I work as an Ethereum core developer on the Nethermind client. Today I'm going to be talking about Surge, which is a base rollup template built by Nethermind. And I'm going to be giving a high-level overview of Surge and how it's accelerating the Ethereum's rollup roadmap. And a big thanks to David Leonardi for making the original presentation this is based on. So rollups are just fancy multisigs. They don't really inherit Ethereum security, and rollups are just slow. So maybe this is a legitimate criticism of Ethereum's rollup landscape today, but really we see this more as a challenge. So how can we actually build a rollup that is more neutral, trustless, all while remaining highly performant and secure? And that's really the aim of Surge. So I'm just going to give a quick kind of background on how rollups do work traditionally. So the high-level motivation for rollups is there are limitations to how much we can scale Ethereum's base layer, all while keeping it kind of decentralized, like the throughput can only go so far. So the idea behind rollups is essentially move all this work off-chain. We're going to process the transactions off-chain and then ultimately post the proofs and transaction data to the L1, where that can all be verified by a smart contract. And traditionally, most of the rollups today work with a centralized sequencer. So this is just one central entity which is going to be responsible for collecting all the user's transactions, ordering them, and ultimately posting it to the L1. So the problem with this approach is there's just going to be one single point of failure. So if the sequencer goes down, then you're not going to be able to get your transactions on chain. And this is also a censorship vector. So if this centralized sequencer decides they want to ignore your transaction, then they're just able to censor you freely. And this concentrates power with this centralized sequencer, and it just relies on the reputation of the entity running the sequencer. One kind of caveat to this is that rollups can have a forced inclusion mechanism, but generally this is going to be, it could be more expensive. It will go through some kind of waiting period, so you can't get your transaction on chain immediately. And you could also be exposed to some kind of toxic MEV extraction. So how can we actually do better than this? And this really is the idea of a based rollup. So kind of the high-level idea here is get rid of the centralized sequencer, and instead we're going to essentially use the Ethereum L1 proposer as the sequencer, and just reuse a lot of Ethereum's proposer builder architecture instead of introducing new infrastructure. So the way this would look is if you are sending your L2 transaction, you're going to send that to a separate mempool. L2 searchers are going to bundle these L2 transactions, and then they'll be sent to the L2 block builder, who is actually the same entity as the L1 searchers. So once the L1 searchers then bundle these transactions, they'll go to the L1 block builder, and then the block will be proposed. So yeah, essentially here we're just reusing a lot of Ethereum's existing proposer builder architecture. And this gives some significant benefits. So for one, we're going to inherit Ethereum's liveness and censorship resistance properties. Again, we're not introducing any additional infrastructure, so this just generally kind of simplifies everything and is a much more cost-effective design. It just generally aligns everything more with Ethereum's base layer, and can also give some composability benefits between different base rollups and with the Ethereum L1 as well. So with Surge, our aim is really to build a neutral rollup. And what do I mean by that? So I'd say a neutral rollup is something that is permissionless, trustless, censorship resistant, open source, and something that anyone is able to deploy and build on. And all of this while still being extremely high performance and secure. And that is really our aim for Surge. So Surge is a base rollup template built by Nethermind. It is stage 2 at launch, meaning it has very strong liveness, censorship resistance properties. It is based. It uses ETH. It doesn't introduce any other token. It burns 100% of the base fee, and it has gigagas performance, so can process billions of gas per second in throughput. And in order to do this, we've deployed on the Tycho Alethea stack, which is the most mature based rollup stack at the moment. But we've made several modifications. So we've replaced the finality gadget. So now we have a 2 of 3 multi-prover system, which I'll speak about a bit later. We've gotten rid of the bond token, which was kind of Tycho bond. Now, as I said, everything's just with ETH. We've changed the fee split. So at the moment, everything is 100% burned, although this is still subject to change on mainnet deployment. We've replaced the execution client from rollup get to Nethermind client, and we've just expanded the documentation a lot just to make it a lot easier for anyone to kind of deploy their own Surge instance. And Surge is stage 2 at launch. So what does this mean? So stage 2 is defined on this website L2B, which maybe you're familiar with, which kind of classifies different rollups according to their sort of trustlessness and security guarantees that you're getting. And on Surge, we have a 45-day exit window. So that means if there's some kind of upgrade happening, then you'll have 45 days in which you can exit your funds. And there are no kind of emergency powers, and there's very limited governance. So essentially, like we're saying, you don't have to trust us. Unlike a lot of rollups today where you might have some kind of emergency powers where they can just kind of make some changes with not a lot of notice. So it's just not really a trustless system. And yep, so it is fully tokenless, so everything is based on ETH. There's no external token introduced, which is going to introduce some kind of outside economic incentives or speculation. And it's just generally very aligned with the L1. And we don't have the kind of overheads of introducing some kind of new token and distributing it, etc. And yeah, it has extremely high performance thanks to the Nethermind client, so yeah, we've achieved a gigagas per second throughput, as has been demonstrated on the base main chain. And this is all thanks to a lot of kind of crazy technical optimizations done by my colleagues also working on the Nethermind client. We have a 2 of 3 threshold system for proving. So we prove with a TEE-based system, SP1 and risk 0, and we need a quorum of 2 out of 3 of these provers to agree for the proof to be valid. So this just generally removes having one point of failure by just having kind of one proving system, because now we have kind of a lot more security and fault tolerance with this 2 of 3 quorum. So yeah, you can get started, like look into Surge today. So check out this website, surge.wtf. You can kind of experiment with deploying your own kind of part of the Surge testnet. You can check out the docs or contribute to Surge on the GitHub, or you can just start playing around on the testnet. You just need to get some hoodie ETH from the faucet and then bridge it over to Surge, and then you can start trying that out today. And we have kind of several power-ups and improvements, or power-ups or improvements as we call them, in the pipeline. I'd say the biggest one probably is pre-confirmations. So we're aiming to have to pre-confirm transactions on the order of like a couple hundred milliseconds. We are working on improving this prover security and the block building, and also kind of really unlocking the benefits of the composability that both base rollups can provide. By sort of having like a unified liquidity layer, synchronous composability between different base rollups and between the L1 also. So what's next? So Surge is a base rollup template, so really it's not designed for end users, but it's really focused on kind of making something for other builders to kind of play with. So we really want the community to take over Surge and kind of deploy their own initiatives based on it. Yeah, we're going to continue to improve the prover finality gadget, make kind of different technical improvements, and of course deploy Surge on mainnet. And one such project, which is planning to be deployed on top of Surge, which maybe you've heard of, is Ethereum R1. So this is a neutral rollup initiative. So it's fully funded by donations, kind of run by builders, and just a public good. So yeah, so I think the plan at the moment is to raise around 1,000 ETH, and then all of the fees that are generated are also going to go to the research and development of the chain, and then after 2030, all the fees are just going to be burned. So yeah, it's just essentially a community-run initiative, community governance, and this is really the kind of ethos of Surge. So yeah, you can check out this website, scan this link to try out Surge. And yeah, sort of on this topic of accelerating the roadmap, I wanted to also mention another project we're working on at Nethermind, which is maybe kind of like a broader thing. We have this project Way, which is about automating the Ethereum protocol development. So this is kind of on the layer 1 as well as like the whole ecosystem. So accelerating Surge rollup or different rollups. The aim here is to have autonomous kind of core developers that can take over parts of my role in terms of development, but also kind of act as a coordination layer between different parts of the Ethereum ecosystem and rollup ecosystems, so that in future, you know, like it'll be even easier to kind of deploy your own rollup, your own kind of, and build more neutral rollups. Yeah. But yeah, this is the talk, and yeah, you can check out Surge here. So thank you very much for listening.
Questions? Yes, from the guest person.
Thank you. Nice talk.
Thank you.
Yeah, I had a question. So you have this 3 tier, like 2 out of 3 proving system.
Yeah.
And 2 of them run is RIS0 and SP1.
Yeah.
I assume this is not Nethermind running in there.
No, not as I don't think so.
So it's okay. Okay, my question is like, I assume it's got to be REST because as far as I know, that's the only thing that works in ZKVMs at the moment. But then how do you confirm the compatibility between the 2? Like, how do you say, okay, you know, 2 of them are running REST, 1 of them is running Nethermind, presumably. How do you, how do you resolve if there's a bug? Because, you know, like a consensus bug, because there are 2 that are pretty much the same client, and the last one is a 3rd. So Nethermind is always out, voted basically.
Well, I'm not too sure, to be honest, on the details of whether Nethermind or Reth are running in them, but as long as any 2 of them agree. I mean, they could disagree not necessarily based on the thing, but on some kind of bug in the prover system itself, right? So I think in those cases, it would still be helpful to have 3. But I think this is one thing that we are working on, is like improving the general resilience of the prover architecture.
Cool.
There was another question, no?
So I assume Surge isn't perfect either. What would you count as major downsides of it?
I mean, at the moment, I guess one of the bigger disadvantages of base rollups is not having pre-confirmations, but as I say, that is in the pipeline. I mean, I can't think of too many other downsides. I think it's quite a big improvement.
Do you have any numbers on proving costs?
No.
So what happens if no 2 out of 3 provers can agree on the output of a specific block, and you can't come to a consensus? Is all the stuck on the rollup?
I think it would be a big problem if 2 of 3 don't come to consensus. But yeah, I think this is going to just be a fundamental issue. So you can like resolve it, I guess, by having even more redundancy or kind of. But yeah, I mean, that's the whole thing of like stage 2 is having minimal intervention governance, right? But then that always comes at the cost of like in an extreme scenario, if the provers can't agree, then like you're kind of stuck, right?
Thank you for the talk. Do you see incentives to that existing layer 2s like not Base maybe, but Optimism and Arbitrum, maybe also Base, switch to a base rollup model? Or is it like network effects that if everything is just layer 1, so to say, or yeah.
Yeah, exactly. Yeah. So this kind of idea of we call it like synchronous composability. So this allows you to unify liquidity between rollups. So you can imagine in a future where there are many like base rollups, then you're going to be at quite a big disadvantage to be sort of outside of that unified ecosystem, right? You're going to become more like fragmented and an island. So at the moment, it's I guess the base rollups are quite small, but we can imagine that potentially many rollups or kind of even smaller rollups could kind of group together and be based and like, you know, have this composability between each other, and then of course tap into the kind of liquidity of the L1 as well.
Yeah, I hope so.
Yeah.
No? Maybe a question for me then. The base rollup, you mentioned like no pre-confirmations at the moment for base rollups, but it's coming, right? You said like it's...
Yeah, so this is in the works. I think we're aiming, I've heard, for around like 200 milliseconds is the aim for base pre-confirmations, but yeah.
Okay. But what's the trick? Like what's...
To be honest, like I'm not like super involved in the pre-confirmation
No,
side, so but yeah, it's obviously a different challenge to with like centralized sequencer, which is much easier to give pre-confirmations.